Welcome back to class time. It's time for CSEC Mathematics. I'm Camille Johnson-Borrell.
And I am Wadian Price.
And today's topic is cumulative frequency. Let's begin. Our focus for today will be draw and use a cumulative frequency curve.
Okay, we will begin with a scenario. Now, the Bamboo Lawn Lawn Primary School has been using the Google Classroom and Google Meet since September 2020. At the end of November, the principal wants to ascertain the performance of her 60 grade 6 students on a particular mathematics test posted in the Google Classroom. Now, this is a table that she saw after an analysis. So here we see that the scores, the frequencies as well.
I'm looking at the test scores, and I am seeing in the first class 0 as the smallest value. And I'm also seeing 10 as my largest, my highest value. Is there a word for the smallest value and the highest value?
Definitely. Right, so what we are dealing with here is grouped data. So in that 0 to 10 that you spoke about, that is the first class. The smaller or smallest number in that band is referred to as your lower limit, while the largest number in that band is your upper limit.
Oh, so that means for class 4, my lower limit would be 31.
Correct.
And my upper limit would be 40.
Exactly.
Oh, I got it. And for my 6th class, my lower limit is 51 and my upper limit is 60.
Definitely.
I'm wondering about frequency. I'm seeing the word frequency.
Yeah.
I remember we learned that in class. I think it was last week or the week before. Can you remind me what frequency is?
Yeah, definitely. So remember, as we have said before, frequency would be how often a particular event happens. So, for example, in this band 0 to 10, the 5 there is suggesting that there are 5 scores in that band. All right? So, just to check if you understand what I'm saying, what would be the frequency in the 3rd class?
In the 3rd class, I'm seeing 22, which means 22 students would have received the test scores within that class, and that class is between 21 to 30.
All right?
Did I get it?
You are correct.
Ooh, I got it.
You are correct.
Upper boundary. Another term. I'm wondering I'm trying to remember what upper boundary is.
All right. So why does the principal need the upper boundary?
Good question.
Now, looking at what she had before with just the frequency, it wouldn't allow her to ascertain the performance of the students, really. She's just seeing, well, 5 students get 0 to 10, 8, 11 to 20. She wants to drill down more into the data. And so she wants to construct a cumulative frequency table. The upper boundary is very crucial when we are constructing a cumulative frequency table, and as we will go to the graph. So the boundary, we are seeing 10, a student may get a score of 10. But what about a student who gets a score of 10.1, 10.2, 10.3, 10.4?
I think maybe that would go in the 1st class with 0 to 10. I think so, you know.
Definitely.
It would?
Definitely.
That's good. I get it. That's good.
Right. So we have to account for those students who would have gotten a 10.1, 10.2, 10.3, 10.4. And so this is where the upper boundary comes in handy. So for the 1st class, your upper boundary would be less than 10.5. So all the students who gets a score of less than 10.5 would be accounted for there.
So that means my upper boundary for my 2nd class would be less than 20.5.
Beautiful.
And my upper boundary for my 3rd class is less than 30.5.
Correct again.
And my upper boundary for my 4th class is less than 40.5.
You're on a roll.
I think I'm getting it, you know. I am getting it. And my upper boundary for my 5th class is less than 50.5. And lastly, my upper boundary for my 6th class is less than 60.5.
You are so correct.
I feel good, I feel good, I feel good.
All right. So if we're constructing a cumulative frequency table, then obviously we need to calculate our cumulative frequency, right? So that is the purpose for, for that last column. Now, what do we mean by cumulative?
In English class, I think cumulative, maybe you keep going on and on. It's like you're adding, so you're adding to what you would have had before.
Definitely.
I'm right?
So we're going to apply that definition.
Ooh, I got it. All right. Explain it to me.
All right.
Maths it up now.
So since we are going to add what comes before to the present one, the first frequency we are seeing there is just 5. There's no other frequency preceding that. So the cumulative frequency for that first class would be 5. All right? What would be the cumulative frequency for the second?
So hold on, man. Hold on. I'm trying to get the first one. So is it that the cumulative frequency being 5 for the first class is because there's no class before that first? Oh, so I have to start off with my 5 there.
My 5 there.
Oh, so that means then that my second cumulative frequency here would have been 13.
All right, 5 plus 8 give me 13.
Oh,
so
I see.
What does the 13 really mean?
The 13 means 13 students would have received less than 20.5.
Beautiful.
And you know what else I just realized? That is how I can link my cumulative frequency to my upper boundary.
Definitely.
I get in it. I'm learning.
All right, so for the third class, so we're continuing. So it will be 13 plus 22 now give us 35.
Yes.
And we continue. 35 plus 12 give us 47. 47 plus 8 give us 55. And then the crucial one, this last one, 55 plus 5 give us 60. Now, why is it important for me to put this in red?
I'm looking, I think when I'm looking at it now and I'm seeing 55 plus 5 and the answer is 60, which is a cumulative frequency.
Yes.
Again, it means 60 students would have received a test score less than 60.5.
Nice.
But not only that, remember the scenario says that it's 60 students. So I am now linking it to my total number of students being 60.
Nice.
So in order for me to test if I'm correct with my cumulative frequency table, I must have the total number that I started out with, which was 60.
Definitely.
I get in it, don't
You're learning.
You're a good teacher. I'm learning.
Thank you. All right. So this is what we call continuous data. Why?
It go on and on.
On and on. So because we have the point 1, point 2, point 3, point 4, that is why we have our upper boundary there for our continuous data.
So if we have continuous data, which keeps going on and on and on, that means we must have another type of data
Definitely.
that can go on and on and on.
Definitely.
But what we call that?
That's what we are going to next. All right, so in this case, we are using basically the same number, the same classes, but our heading change a bit. Now we are looking at COVID-19 cases. That first class, 0 to 10, let us say there are cases in particular communities. So we are saying there are 5 cases are in the 0 to 5 band.
The
right?
0 to 10 band, don't
0 to
it?
10
Yeah.
band. But when you look at the next column, you're not seeing boundary. We're seeing limit. Why couldn't we have boundary? Couldn't we have 8.1 case?
I don't think so, because you're saying now that we're looking at COVID-19 cases. And if we're looking at COVID-19 cases and we're talking about people here, I have never seen half a person. It's either you have it or you don't have
So
it.
what about those with mild symptoms?
If you have mild symptoms, you have it.
Still
You
have
would
it.
have been classified as having it. So it's either you have it or you don't have it. So that means for the upper limit, there's not going to be any point, because you can't have half a person.
Right.
I can't have
Definitely.
half of me, nor a quarter of me. So it must be a whole number.
Exactly.
So which means
Right.
our upper limit for a first class would be 10.
Exactly.
Let's
Right.
see if you get it. What about the second class?
Second class with a 20.
Oh Lord, I give it when don't
Third
worry
class,
yourself. Third class.
30.
30, you sure?
I guess
Yes,
so.
you're
Yes.
right, you're right, you're right.
Fourth class, 40, fifth, 50, and then I get 60.
Yes, good job.
All right. So for our discrete data,
So this is the discrete data?
this is the discrete data. So we're dealing with only whole number values. Only whole number values.
So we have continuous data and we
And
have
discrete.
Oh, I
All
get it. I see, I see.
Nice.
So since as we have all of this information that the principal has, she placed it in a table.
Yes.
You think she can now put it maybe in a graphical representation?
She definitely can.
No, we're
definitely
getting
can.
deeper into the lesson, you know, we're getting deeper. So let's see what's happening.
All right, so here she has her grid, and she have her cumulative frequency table that she had just constructed. Now on the grid, we realize test scores are on the horizontal axis, while cumulative frequency is on your y-axis, your vertical axis.
Yes.
And this will always happen. Your cumulative frequency will always be on your vertical axis. And then whatever else you're using, your test scores, your marks, your COVID cases, those will be on your horizontal axis. Now she is going to plot these points now. Now this is where it is crucial. What do I plot on my graph?
Well, if we're looking at our upper boundaries, which is our test scores and our cumulative frequency on our y-axis, I'm going to look at my table, and my first point is 10.5, and it's mapped on to 5.
Right, but which one of the 5? The
No,
5
the
in the cumulative
frequency, man, the cumulative
Nice,
frequency. So that
nice.
means I'm going to look for my 10.5 on my x-axis,
Yes.
and I'm going to now try and find where 5 would be located on my y-axis. So here I have point number 1. So I'm plotting my points. And when I plot my first point now, I'm going to look at my second point. So it's 20.5 and it's mapped onto 13. So there goes my second, my third, my fourth, my fifth, my 6 points. I guess
Nice.
what I would do now.
Just connect the points.
That me I say, connect it, but it's not just connecting, you know. I must get a curve.
Definitely.
I have to get a
Definitely.
curve.
All right. So this is what is called your cumulative frequency curve or your ogive curve, right? So you'll hear those two words being used. So this is a normal form for a ogive curve. So based on the spread of your data, the curve may stretch a bit, but it will still take on this general form. All right?
All right, all right. Let's take it a little bit further now. So important terms related to the cumulative frequency curve. 1, quartile, 2, interquartile range, and 3, semi-interquartile range. But since we're looking at these 3 terms, let's really look at what each means. So let's look at the quartiles. Now a quartile is a group of values that divide a data set into quarters or groups of 4. Don't be confused here. A quartile is a value,
Exactly.
not a group of numbers. So here we have a set of numbers. Here we have from 1 to 11. And we're seeing here that 6 would have been our middle quartile. So here 6 being our middle quartile, we call it our median.
Yes.
And we represent it using Q2.
Q2.
Right? And if we look at the 6 too, we realize that we have 5 numbers to the left and 5 numbers to the right. You think they have any more quartiles right here, so?
Well, let us check. Right? So as you have mentioned, the 6 would divide the data set into halves, which really have 2 quarters.
Yes.
Right? Now to the left, we can also divide that data set in half. Right? So here we see that the 3 there would fall right in the middle. Right? So the 3 would be like the median for that left side of your data set.
All right.
This is what is referred to as your Q1. Right? And then if you do the same thing to the data set on your right, the 9 here would fall in the middle. So it's like the median for that right side of the data. So here we have now the data set being divided into 4 segments. So although we are talking about quartile, you won't see a Q4.
That's what I was going to ask, because I'm only seeing Q1, Q2, Q2, Q3, and we're talking about quarters. So I'm wondering, where is that next quarter?
Yeah. So the data set is really divided into quarters. So 1 and 2 in the first quarter, 4 and 5 in the next, 7 and 8 in the other, and then 10 and 11 in the
next
fourth.
quarter. Oh, I see. So apart from quartiles, we need to also know about interquartile range. And the interquartile range is a measure of statistical dispersion, which is spread, which is equal to the difference between the 75th, which is 3 quarters, and 25th, which is a quarter percentiles, or the difference between the upper and lower quartiles. The interquartile range is a better measure of spread than the range, as it only uses the middle half of the data that is grouped around the median. This means that unlike the range, it is not subject to extreme values.
Yeah, definitely.
You think you understand the mouthful that I just said?
I understood.
You understand it?
Clearly.
You're sure?
Clearly.
All right. Let me see if you can talk to us about the range now right here.
All right, so looking at this range, so here we have a set of data, the ages of 12 students. Now, as we know how to find the mean already. At all the data set divided by the total number there, we got 8. Now, our range, as we did in previous lesson, is just the difference between your highest and your lowest value. So the range here is 13 years.
Yeah.
All right? Now, looking at the same data set, we are going to apply now the interquartile range and to see the difference. So the median remained as 8 because that's a middle score, middle number there. The interquartile range now, as you have explained beautifully before, is the difference between your Q3 and your Q1.
Which is my upper limit and my lower limit.
Our upper quartile.
Oh, you know, I was checking to ensure that you're listening to me. Good, man, good. So it's upper quartile and lower quartile. All right, all right.
So your upper quartile here is 9, while your lower quartile is 6.
6,
right? So 9 subtract 6 would give you 3. So here we have a different spread in the data. So interquartile range is saying the spread is just 3 years, while your range, the spread is 13. So here we see, because if you look at the numbers really, 4, 5, 6, 7, 8, 9, and then 17, this is not a really widespread. So the 13 there would not give you a good estimation of of the spread really.
Of what's happening.
Right,
okay.
but the interquartile range is more accurate.
All right. And since we're looking at interquartile range, we also need to know about our semi-interquartile range, which is a measure of statistical dispersion, which is equal to half. Remember, semi is half. So it's half the difference between the 75th and 25th percentiles, or the difference between upper, and so it's half the difference between the upper and lower quartiles. So let's see if you understand what I just, remember what I just said? No? Let me see if you understand it. All right. Talk to me about this one here.
All right. So this data set, no, it is even the one we looked at the last time, that was an odd number.
No, okay.
Odd number amount of data set. This one, even number. So because it is an even number amount of data set, then 2 numbers are going to fall in the middle. So 8 and 9 would fall in the middle here. Right? What we'll have to do is to add both of them, divide by 2, and that will give us our median. So our median in this case will be 8.5. All right?
Yes, I see it. I've seen it. I'm seeing
nice.
it.
While your first quartile would be 6, upper quartile will be 10, as we have done before. So your interquartile, difference between your upper and your lower, divided by 2.
That's my semi, don't it?
That's your semi.
All right. So which means then that it would have been 10 subtract 6, all divided by 2.
And
which when we simplify it, bam, we get 2. We're getting it, man. We're getting it. So now we know how to do our semi-interquartile or interquartile range. What else we know again? We know about the quartiles. Yes, we know about the quartiles, the median, the lower quartile, and the upper quartile. Nice. But I want to know, because I'm learning about math, but I want to know how to apply all of this that I'm learning, you know.
That is what we're going to do
You
now.
sure we're going
We're
into
gonna
it now?
apply all that you have learned before.
All right, I'm watching you. So let's go.
All right, so this is a graph that the principal would have constructed before, and she wants now to ascertain some information. So she wants to find now her median. What is that score that falls in the middle? So she's finding her Q1 or her Q2 first,
Yes.
because the Q2 is the median.
Yes.
Q2 would be a half of the data set. Here we find that half of 60 is 30. 30 now just give you the position.
You know, is that I used to do when I got to high school? I used to just find half of the data, which is half of the 60, which is 30, and I just write it down. And when sir give me it wrong, I always wonder what is going on, because that sir teach half of the data. But now it's clearer to me. I'm looking at the graph because I'm using my curve now, my cumulative frequency curve, to now answer the question. So I'm understanding now.
Right, so the 30 there just shows us the position of where the median is. So we draw a dotted line from 30 to the curve down to the horizontal axis, and we are seeing there that the median is about 27 marks.
Approximately
right? And again,
27,
it's an
don't it?
estimation.
Yeah, that's
right?
what
Because
I was
based on
wondering.
how you draw your curve. However, as we know with estimation, you can't be too far out. So your answer could be maybe 27, 27.5.
Or even 26.5.
26.5, but you couldn't get like a 30, 40.
That would be too
That
far.
would be too far out. All right? Then she went on to calculate her lower quartile, which is her Q1, which would be a quarter of the data set. So a quarter of 60 would give us 15. Again, 15 is just the position.
Just the position.
Just the position.
Just the position.
All right, so dotted line to the curve, down to the horizontal axis, that is approximately
21
marks.
All right.
All right.
So let me try the upper quartile. Let me try it. So my upper quartile would have been 3/4 of my data set, which is 3/4 of my 60.
Yes.
So I'm going to locate my 45 on my y-axis, which would have been here. So I'm representing it here. When I find my 45 on my y-axis, I'm not going to write down 45.
No,
that's not the answer.
That's not your answer.
I need to know, draw my dotted lines to the curve. And then when I draw it to the curve, I try to find the coordinating x value, which is the coordinating test score.
Definitely.
So when I draw the other dotted line now, I realize that it's 38, approximately 38. All right. But in looking at this now, I know the lower quartile, I know the upper quartile. I think we must find the interquartile range too,
We
you know.
can.
What's the what's the name again? Interquartile range. It's the difference between the upper quartile and the lower quartile. And we know our upper quartile, which is 38. We know our lower quartile, which is 21. All we need to do is subtract. So when we subtract that now, we arrive at 17 marks.
That's nice.
We have enough information?
She should. I think the principal should have enough information there, because her interquartile range now is showing her for the interquartile, the middle quartiles, right? So that middle half of the data, she wants to see how many students are really in there, how many scores are there.
In there. All right, I get it. I'm getting it.
All right, so this is what happened at her school. The cumulative frequency curve here now gives the information on the performance of the grade 6 students at Bambolan Primary. Now, students whose performance is below 35 will be offered intervention sessions, while students whose performance is about 50 marks will be awarded. So the principal now, having this Ogive curve, having her quartiles and all of that, she can now ascertain who should get intervention and who should be awarded. All right? So the number of students who need intervention How can we determine that?
You asking me?
I'm asking you.
I was just going to ask you.
All right, since you asked me, I'll tell you.
Oh, nice.
All right, so 35 marks, below 35 marks would be offered intervention. So since we're talking about marks, I cannot find 35 on my vertical axis because these are not marks, these are students.
I get in it. It's a good thing. I'll let you explain first, you know, because I would run to the y-axis quick.
Right, because when we started out earlier, when we were looking at our quartiles, we start our y-axis, go out, our vertical axis, out to our curve and go down.
You're right.
So students normally believe that that is what we do every time. All right, so we find 35 because they are marks up to our curve, then out. That will give us approximately
42.5.
42.5.
42.5. 42. I'm sure. 42.5.
All right,
But hold on.
So maybe you're the 0.5 student?
That's what I was just going to say, you know, because you can't have half a person.
Well,
So it can't be 42.5.
I don't think you want to be that girl to be 0.5.
No, I can't be half a girl. So that means it would be around 42 or 43.
Somewhere,
so approximately
there.
42 or 43.
All right. So approximately 42, 43 students would need intervention. Now, I can just imagine how that principal looks. There are 60 students in the class. Approximately 42, 43 of them needs intervention.
Needs divine intervention.
Maybe divine.
Yes, my
All
dear.
right? Now, let us see how many students would actually be awarded. So again, we find 50 because the mark, those who get 50 or maybe above would be awarded. So we find 50 on our horizontal axis, up to our curve, and out. Tell me what is happening here now.
55, me get this, 55 students. I'm sure, 55 students. Tell me I'm right.
All right, let us see if you're right. So
But
42.
I'm almost right. Look there.
Yeah,
That is on the graph, 55. You don't see it?
Yes, so I'm going to prove to you that you're right.
Okay.
So how many students are in the class?
60.
60. How many out of the 60 need intervention?
Approximately 43.
All right, so 43. Right, and how many are going to be awarded?
All right, fine. I see my mistake. So
Okay.
it's not 55. So I would have to look because there are 60 students in the class. And if it's approximately 55, I would have to subtract.
Definitely.
So it would be 60 subtract 55, which leaves me with only 5 students. But guess what? I am very sure I am a part of that 5 students who will receive an award.
We will see.
I'm not sure about you, but I'm sure about me.
We will see.
But we think they get it, we think they're learning.
They get it, and I think the principal now, although uncomfortable, knowing that more than half of her class needs intervention, she now has enough information that she can use to drive her plans.
You know, I've learned from this session today. But let's take it a little bit further. Let's see who is following and who is paying attention. So let's go into a CSEC question. And I want to be the first student to try this one. So the CSEC question says, the table below shows the ages to the nearest year of the persons who visited the clinic during a particular week. We're going to complete the table to show the cumulative frequency. So let my brain work now. So I'm giving them a chance at home to try. 30 seconds to try at home, guys. And I'm going to try too. So here we have cumulative frequency. The first one is 4. And then I'm going to add 4 plus 11 to give me 15. Nice. So that means I'm going to add 15 plus 20, 15 plus 20, 15 plus 35. So when I have 35 for my third class, I'm going to now add my 35 plus my 12, 35 plus 12, 35, 47. So when I add my 47 plus my, 50, I'm right. 100% price, 100%.
You are correct. Question. What type of data set is this? Discrete or continuous?
Wait there. Discrete or continuous? We're looking at age. I think this would have been continuous. What do you think? You think I'm right? Continuous, don't you?
Definitely.
All right. And see there? See there now?
You were
I'm
right.
right.
You were
So we have
right.
the completed table, and I hope you at home got it right. I am indeed correct, and you should be correct too.
All right.
You want us to step it up?
Definitely.
Let's step it up.
All right, so here you're asked now to use a scale of 2 centimeters to represent 10 years on the x-axis. That's your horizontal axis. And 1 centimeter to represent 5 persons on the y-axis. And we're going to draw a cumulative frequency curve for the data. That's 5 marks.
But hold on there, man. Hold on. Let's take a step back. So I'm stepping back, because I'm trying to remember what I learned today. So in doing my cumulative frequency curve, I need to know it would help me then to know my upper boundaries or my upper limit, depending on which data I'm using. And it would also help me, it's a cumulative frequency curve, so I must know my cumulative frequency.
Definitely.
Which we would have found before. So now we're short of our upper boundaries. So we have to know our upper boundaries before
Definitely.
we can do that curve, don't it? All right, so after we know our upper boundaries, then what is the next step we're going to take? We're going to what? Use the graph to estimate something.
Some things, yeah.
So using the graph to estimate the median age for the data, the probability that a person who visited the clinic was 75 years or younger. And just a hint, draw lines on your graph to show how these estimates were obtained.
All right.
All right, so we give them enough time to try the graph, don't it?
I think they had enough time.
Let's give them 30 more seconds because we know that we never do the upper boundary before. So now they're trying to find the upper boundary, which is easy,
Very
That's
easy,
man. And all they're going to do now is plot the points. So we know that on our y-axis is cumulative frequency on our y-axis. And on our x-axis, which is our horizontal axis, we would have the age in years, don't it?
Definitely.
Nice. So we know what will be on our horizontal axis. We know what will be on our vertical axis. And all we need to do now, when we have our table, plot the points. After we plot the points, we just draw the curve.
But there's one other thing they need to pay attention to.
What is that? What is that?
The scale.
You know that's important?
Very important.
Because I would just be there drawing, and when I look, I can't even plot all my points because some of them drop off my graph sheet. So it's a good thing that you remind me about my scale. So my scale is very important. So we have to pay attention to our scale. So let's take a look then. So here we have our upper boundary. So we have added the column for our upper boundary. And here we have our graph.
All right. So our graph is here. All right. Again, we see the normal form that the graph takes on. So we know that it is a cumulative frequency curve or an ogive curve. So now we can answer the questions posted. Now the median age for the data. Median. What does median means again?
Hold on, man, hold on. Halfway.
Which is your Q.
Half of my Q2, which is
Your
half of
Q2.
my data. All right.
So there were 50 students there, right?
Yes.
So 50. So half of 50 definitely is
25.
So from 25 out to my curve.
Hold on, no, man.
No.
Let me remind them because I don't want them to make the same mistake I made in high school, So it's not that after you find the median here to be 25, you're not just going to write down the 25. You have, because the 20, why are we not writing it down? You call a P word. Position,
of where the
right.
median
So
is.
we're not going to write down 25 because 25 is just the position. So we have to use the curve to now find out which age is halfway between.
Definitely.
I'm getting it, don't
All
it?
right.
I'm learning.
So from 25 to the curve down, we are seeing approximately what?
Approximately 64. 64 or 65. So
Yeah.
we're seeing approximately 64 or 65.
Yeah, so anywhere in that range, and we should be good. We should be good. All right, what about the second question? The probability that a person who visited the clinic was 75 years or younger.
75 years or younger. Lord of mercy.
How would we find this?
I stuck bad. You have to go help me out. But I know that with probability is a chance.
It's a chance.
Yeah, man, is a chance, you know.
Right.
So as the question and the statement here says, the probability that a person visited the clinic was 75 years or younger.
Or younger. So 75 years.
So
Which axis has years?
oh, because I was looking on the cumulative frequency a while ago, you know. When I looking, I don't see 75 years. I see 50 being the largest value. So I was wondering how you're going to do it. But all right, I'm looking on the x-axis. So when I look, oh, it's years for real.
Yes.
See it there? So that means I would look for my 75 on my x-axis.
All right. So we find 75 on your x-axis, up to your curve, and then out.
So that's approximately 43.
About 43.
Yes, 43
All right.
on my y-axis there, which means it would be 43 out of?
Out of the 60. 60 or 50?
It's 50, man. It's 50. You're going back to the primary school.
43
no, man.
out of the 50.
Nice.
Right?
We think they learn anything today, though?
I think they
Yeah.
do.
But
They do.
let's just do a nice little recap then. So we looked at, we know that the focus of our lesson was to draw and use the
use.
cumulative frequency curve. And in drawing and using the cumulative frequency curve, we know about our quartiles.
Right.
And what you said again about quartiles being 4 quarters
Yeah.
is we have the lower, we have our which
Middle.
is Q1, we have the middle which is Q2,
And
we have
then-
the upper which is Q3.
Definitely.
All right, so 4 quarters right there. So the other thing we learned about too was our interquartile. Shh, don't tell me. Shh, I get it. So our interquartile now. What is, it's Q3 subtract Q1. The difference
Nice,
between
nice.
our upper quartile
And
and our lower
quartile.
quartile. All right, I getting it. And guess what now?
What about your semi?
My semi, I can walk, you know, because me know this one. Semi means half. And interquartile, I would have just expressed difference between upper quartile, lower quartile. So the semi has to be half of my interquartile, which is half Q3 minus Q1. I'm at it out.
Definitely.
I feel good.
I feel good for you too.
And you feel good for me
Yeah,
too?
yeah,
All right.
definitely.
Christmas is coming. Sorry, you know. All right. But I am happy for them. I'm happy for them, you know. They would have learned how to draw and use a cumulative frequency curve.
Definitely. Okay, so that's it for today's lesson.